Hi, in this session we'll see sway analysis problems using slope deflection method. Analyze the portal frame and then draw the bending moment diagram. You can see a frame here with an eccentric point load 80 kN on BC and spans you can see in the figure. So this is a symmetrical frame and unsymmetrically loaded. Thus it is an unsymmetrical problem and there is a sway. So assuming sway towards right side. So as there is a fixed support at A, theta equal to 0, theta D equal to 0 and theta B is not equal to 0, theta C is not equal to 0. So first of all we need to find the fixed end moments MPC equal to minus WAB square by L square and MCB WA square B by L square as it is eccentric point loads. From here we will get minus 56.25 kN meter and 93.75 kN meter. Remaining are 0 because there are no loads on AB and CD. So next slope deflection equations. MAB equal to MFAB plus 2A by L 2 theta A plus theta B minus 3 delta by L. So 0, MFAB is 0. So 0 plus 2A by 4 into 0, theta is 0. So plus theta B minus 3 delta by L. So here you will get first equation. In the same way MBA, you will get second equation. MFBA plus 2A by L theta A plus 2 theta B minus 3 delta by L. Similarly MBC. In MBC and MCB, theta B and theta C are unknowns. Similarly, MCD and MDC. In MCD, theta D is 0 and MDC also theta C is 0. But delta is not 0 here. Delta is 0 only in MBC and MCB. Note this point here. Delta is not 0 in MAB, MBA and MCD, MDC. Delta is 0 in MBC and MCB because BC is a beam. So sway will be only for columns, not beams. Note this point. So in the above equation there are three unknowns theta B, theta C and delta. Accordingly the boundary conditions are joint conditions. So here we have an extra we have joint equilibrium conditions as well as one other condition, that is shear condition. Joint equilibrium equations are MBA plus MBC equal to 0 at B, at C MCB plus MCB plus MCD equal to 0. Along with this we have shear condition. HA plus HD is equal to 0. So at A support we assume HA towards right side and at D we assume HD towards right side and MAB, BA, MCD, MDC everything we'll assume to the clockwise direction, and then if we apply sigma moment about B equal to 0 we will get HA, applying sigma moment C about C equal to 0 we will get HD. So HA we will get as MAB plus MBA by 4 and HD we will get as MCD plus MDC by 4 equal to 0. Therefore MAB plus MBA plus MCD plus MDC equal to 0 is the other condition. This is known as shear condition. So using these three conditions we can solve the unknowns. So this is how we get the shear condition MAB plus MBA plus MCD plus MDC equal to 0. By applying moment about C equal to 0, moment about B equal to 0, we will get this shear condition. So applying joint equilibrium condition at B, we will get 7th equation. At C, we will get 8th equation, and the shear condition, applying shear condition, we will get 9th equation. So substituting this 9th equation in 7 and 8, we will get 10 and 10th equation and 11th equation. Solving 10th and 11th equation, we will get theta B. Substituting theta B value in equation 10, we will get theta C, and then we can find delta. Then substituting in 1, 2, 6 equations, we can find the final end moments MAB, MBA, MBC, MCD, MDC, etc. So we can find all the moments. So you can see this figure here, the moments and the moments are shown here, clockwise and anti-clockwise moments. Then we will find the reactions. So for column AB, HA equal to the 34.69 plus 55.31 divided by 4 equal to 22.5 kilonewton, applying sigma moment about B equal to 0, and for span BC applying sigma moment about C equal to 0, we can find HA and HB, RB and RC also. By applying sigma moment about B equal to 0 for AB, we can find HA, and by applying sigma moment about C equal to 0 for BC span, we can find RB, RC, and applying sigma moment about C equal to 0 for CD column, we can find HD. And now there is a check here, sigma H equal to 0, HA plus HD should be 0. So here to 22.5 minus 22.5 equal to 0. Now we can draw the bending moment diagram. Here first for simplicity for point load, and then final end moments. The sign conventions you can see in the right side here. Based on that we can draw the bending moment diagram. Coming to the next problem, here this is also a sway problem because there is a UDL on span AB, point load on span 90. So here load is unsymmetrical, therefore it is also a sway problem. The frame is symmetrical but loading is unsymmetrical, hence there is a sway. Assume sway towards right in this problem. So first step is fixed end moments MFAB, MFBA, MFBC and MFCB we need to find because there are loads on them. On CD there is no load. So as there is UDL, so final end moment formula are minus W square by 12 and plus WL square by 12. And for on BC minus WL by 10 plus WL by 8. Then slope deflection equations. So here MAB, in MAB theta A will be 0, remaining are unknowns, theta B, delta are unknowns. In MBA also theta B and delta are unknowns, theta A is 0. In MBC delta is 0, MCB delta is 0 because it is a beam. So there will not be any sway for beams. Sway will be only for columns. So for MBC and MCB delta is 0. For MCD and MDC theta D is 0, remaining are unknowns. So we will get 1 to 6 equations. So here theta B, theta C and delta are unknowns. We can find these unknowns using the joint equilibrium conditions and shear condition. So joint equilibrium conditions are MBA plus MBC equal to 0 at B, at C MCB plus MCD equal to 0, and other condition is shear condition. HA plus HD is equal to minus 40. HA can be found by applying sigma moment about B equal to 0. HD can be found by applying sigma moment about C equal to 0. So we will get MAB plus MBA plus MCD plus MDC plus AT is equal to 0. So applying all these in the equations, we will get 7 and 8 equations. Then we will get the ninth equation by solving these above equations. In that way we can solve the unknowns. So after getting the unknowns, we can substitute it from in first equation to sixth equation. We can find the final end moments. Now you can see the figure showing the moments, all the end moments here. Then the check. For the check we need to find the reactions first. So by applying sigma moment about B equal to 0 we can find HA. By applying sigma moment about C equal to 0 we can find HD, and then for CD, and then applying sigma moment about C equal to 0 for BC span we can find RB and RC. Here RB and RC are reaction at A and reaction at D. So then you can draw the bending moment diagrams for the final end moments and for the loads. This is the third problem in a sway frame problem. Analyze the portal frame and draw the bending moment diagram. You can see the portal frame here, which has a two different levels. Supports are at two different levels. That means length of the columns are different. So this is an unsymmetrical frame as the lengths are different for the columns. You can see a UDL on BC. No loads on AB and CD spans you can see in the figure. So theta equal to 0 as there is fixed support at A, theta D equal to 0 as there is fixed support, theta B is not equal to 0 and theta C is not equal to 0. Therefore it is an unsymmetrical problem, hence there is a sway, assume sway towards right side. First we need to find the fixed end moment. So MFAB becomes 0, MFBA is 0 as there is no loads, and similarly MFCD equal to 0, MFDC equal to 0, and MFBC equal to minus WL square by 12 as there is a UDL there. So minus 41.67 kN and MFCB plus WL square by 12. Then slope deflection equations we need to apply. So in MAB equation, theta A is 0, theta B delta are unknowns. In MBA, delta same, theta A equal to 0, theta B delta are unknowns. But in BC and CB, delta will be 0 as it is a beam. So sway will be only for columns, not for beam. Therefore delta is 0 for MBC and MCB. And for MCD and MCD, For MCD and MDC, theta C is unknown, delta is unknown, theta D is 0. So you'll get 1 to 6 equations, slope deflection equations. Then apply the joint equilibrium equation conditions and shear conditions. At B, MBA plus MBC equal to 0. At C, MCB plus MCD equal to 0. Here shear condition is HA plus HD equal to 0. So applying sigma moment about B equal to 0, you will get HA equal to MAB plus MBA divided by 3. Applying sigma moment equal to C equal sigma moment about C equal to 0 for CD column, you will get MCD plus MDC by 4 equal to HD. So HA plus HD plus 40 equal to 0. So 4 in you will get 4 into MBA plus MBA plus MAB plus M3 3 into MCD plus MDC equal to 0. This is a shear condition. So now applying all these conditions, we can find the unknowns. So by applying this joint equilibrium equation condition and shear condition, we can find the unknowns. So substituting these values again in 1 to 6 equations, we can find the final end moments. Then show all these moments in the figure, and then there is a check here. We can calculate HA by applying sigma moment B about B equal to 0. We can calculate HD by applying sigma moment about C equal to 0 for CD, and then we applying sigma moment about C equal to 0 for BC, we can find RC and RB, which are equal to RD and RA. Then we can draw the then there is a check, HA plus HD should be it should be 0. That is a condition. So now you can draw the bending moment diagram. Thank you.